They are known as types of float. We have three types of float, which is known as total float. Also, second one is free float. Third one is independent float. The total float is a measure or the flexibility that a particular path or particular activity is given by total float, which is equal to latest start time minus earliest start time. That gives us total float. In other words, we can express that as latest finish time minus earliest start time minus the duration of that particular activity. For any activity, when we are trying to calculate total float, we have to use this kind of equation. That means latest start time minus earliest start time of that activity, or which can be also expressed as latest finish time of that activity minus earliest start of that activity minus duration of that activity. Similarly, we have free float. Free float is given by earliest finish time minus earliest start time minus duration of the project. So, this way we will try to calculate this free float. And we have another float known as independent float, which is given by earliest finish time minus latest start time minus the duration of the particular activity. So, this way we will calculate independent float. So, while trying to get the float, we have two methods to find out the float. That means when we are starting from backwards, that means we will start from the end of the project and we move towards the starting point of the project, and we try to find out what is the flexibility that is associated with each of the activity lying on that particular path, which is known as backward pass. Or we have another kind of method which is known as forward pass. Forward pass indicates that we start from the starting point of the project and move towards the ending point of the project on the network diagram. On each of the path we try to. But one thing we should know is, for the activities lying on the critical path, there is no float available because they cannot be delayed under any circumstances. That is the reason we call them as activities lying on the critical path, or that path itself is critical path, because any delay occurring or happening on any activities lying on that path will result in the escalation of duration, or the project duration will increase. So this is the way we try to calculate the flexibility or float on for each of the activity on different paths. And earlier we were discussing that there would be three time estimates for the PERT diagram. That means optimistic time is there, pessimistic time is there, most likely time is there. So when there are several activities that comprise a project, and then it really becomes difficult for us to estimate the duration of the project. Say there are 20 activities lying in a project, which time we need to take, whether we need to take pessimistic time, whether we need to take optimistic time or most likely time. So that becomes very complex in estimating the duration of the project. So all these three time estimates are combined into one single time estimate, which we call that as expected time. This we will use optimistic time, pessimistic time and most likely time, and we calculate one single estimate or time duration of each activity, which we call that as TE, is given by TO optimistic time plus TP pessimistic time plus 4 into TM, that means 4 into most likely time whole divided by 6. This gives us the expected time. That means we have converted these three time estimates into one single time estimate, which will enable us or which will facilitate us to find out the project duration, because now we have only single time estimate for every activity lying on the diagram. So this we use and try to find out the duration of each path and find out the critical path. That is how we try to find out. Then similarly we want to find out standard deviation of the project. That means to what extent the project can be delayed, what is the earliest possible time, latest possible time to complete. This will be estimated by using the standard deviation. Standard deviation is calculated for the activities which are lying on the critical path, and they are added together so that we will have the total standard deviation for the entire project. Because project duration itself is represented by the duration of the critical path, so we need to calculate the standard deviation of each activity lying on the critical path, and then we have to sum up, which will give us the total standard deviation of that project duration. The standard deviation of the project is given by this particular equation. You can look at and you can calculate the duration as we have discussed earlier. Similarly, all of us are concerned after estimating the project duration, we are interested to know whether the project is going to be completed on time, or whether it will be delayed, or whether we can complete it early. We are concerned. So in that event, what we try to do is we try to find out a measure known as probability of completing the project for the estimated time or for some given time. So in that case, say for example, a project is to be completed in 36 weeks. We wanted to know what is the probability of completing the project in 40 weeks. In that case, we try to use those dates. That means the normal completion time and the time which we are prescribing, this 40 weeks, what is the probability, that is given by this equation. So this equation helps us to know what is the probability of. So we will find a value known as Z. Z represents the area covered under normal distribution curve. That area covered under normal distribution curve will show us the probability of completing the project for a given time.